guys, I'm Łukasz. I'm lead Gen AI engineer. Today we dive deep into the Qwen 3.5 multimodal model on video and images. We'll look into how to speed up the inference. So instead of watching this running for around 20-30 seconds on the 2 minutes MP4 video, we'll lower it into just 2 seconds, just like this. So here we have the same video. We click run and we get response in 1.5 seconds. So now let's dive how we do it. So now we do a quick reminder of the hardware that we use. So we have the 590 driver, RTX 6000 Pro workstation, CUDA 13.1. And on the CPU side, we have the AMD Ryzen 9950X 16-core processor. We now go into the lab that I created. We can see that there are multiple parameters here, and I prepared all of this. Why? Well, on the front ends that are available for LLMs like OpenWebUI, LM Studio, Ooga Boonga, all of these kind of things, the support for images and for video is really not there yet. So to allow us the speed ups and experimentation, I created this simple GUI on Gradio that runs with vLLM on Docker, so we can perform the experiments and also present how all of these parameters change the model output and so on. And we'll not play, for example, with temperature, top P, K, present penalty, and frequency penalty. Why? Because we'll follow the guidelines for the video image model that are on the model page. We'll use the 4 billion version because that's what most people can work with, but you can always use lower, higher version, up to you. And then for the usage, when I created all the code, and if you want to create it yourself, there is vLLM Qwen 3.5 usage guide, how to run it with images, hardware, and so on. So now, next steps. So now, quick overview of the Docker that we'll use for the lab with few changes compared to the last one. So basically, everything is similar. So yeah, we do HF home, HF hub to load the model from default directories. For the Blackwell, this is actually advised to use nightly build, so we'll use it because I have Blackwell GPU. I mount the env variable, but it's not really also that necessary. Also because I have Blackwell GPU to avoid potential CUDA compatibility that I have before, I use the no op config file on the Blackwell, so just this, but otherwise you don't need it, and it will be probably commented on the repo. So the model, the host port, I set it to one sequence because I think in this video we'll focus on all the other steps than like multi-processing, chunking, and so on. I think I will need to do it as a separate video because that's a lot to cover. The GPU memory utilization, I just put 0.5. You could optimize it for your GPU. This basically defines the fraction of GPU memory vLLM may use. And then on top of it, it's adding basically other things, because it loads weights, CUDA graphs, and so on. Then the max model length. So this is the maximal total tokens that we can have. So input and output. I set it on 20,000 for the test, but typically you can optimize it and lower it because it also gives you some big gains. And then the multimodal encoder TP behavior. So this is also all from the vLLM guide that I showed you. We will mount the processor for video images tensors into the system RAM. Then I limit it to 8 images and 1 video for now, because I don't think you'll need more. Actually, I think for this we'll just use 4, so let's not put 8. And then server media IO behavior, So basically on the startups we need to define if we have fixed frame cap at IO stage. So this is for the video image processing. And then we also need to define a default sampling behavior. We will modify it later, the reasoning parser. And this is the interesting part because models and vLLM, especially when you run things, as we can actually see here, you have KB cage and then prefix cage. But when you do video, there's also cage. So basically it stores the already loaded images or videos there. But if we do it, and I want to present something where we run multiple things on the same image, because the image or video is not very important here, then I didn't want this cage to work. So I set it to 0, and later we'll set it up so we can see actually the gains from caching and running inference on same or similar images and videos. Okay guys, so in the meantime I run vLLM because the startup takes quite time, depending on your optimization setting and so on, but for our Docker it takes quite some time. So because we use the nightly image, I wanted to show that this is the version of the image and the server that we pulled. Because if you go here and you pull before the same image, then if you use this tag, it will pull the one from your cage. So you need to delete the image and then run it, and then it will pull the newest one. That's how Docker works. Well, in short. And I use Docker in VS Code. And if you go here to plugins, you can just install Docker plugin, Python, and play with it. The code for the GUI I will also attach, but I will not go deep into it because it's not fully finished. So we can see the parameters that we set up here, basically. And then the other important part, we get some errors because there is still issues on Blackwell and so on. The errors are, here. So input tensor shades format mismatch. So I read there is a few issues on the GitHub, but it will take some time to figure out and everything. So we will work with what we have basically. And because I have a lot of GPU for this model, then the KV cache is quite high. It's 267,696. And as you can see, we have maximum concurrency for 20,000 tokens because that's what I set in a vLLM per request. So we can basically manage 49 requests. So but this is for the text models, 15, because we defined that we can only do 1 video and 4 images. And now if we look into this, before I start, I want to just let you know about one thing. So basically there is vLLM guide on optimization because as I told you, it was loading for quite a lot of time. So actually here there is description of like chunked prefill, how to optimize it, tensor, expert parallelism, data parallelism, and so on. We could dive deep into it and actually would like to visualize it so everybody could understand. And then also the quite important part is conserving memory because here we can get already tip about what we will talk about. So for certain models, you can adjust the multimodal processor argument to reduce the size of the process multimodal inputs, which in turn saves memory. Hey guys, so the first optimization that we can do for the Qwen 3.5 is to play with these parameters. So what we have here, max tokens, this is what we set up in Docker, so it was 20,000. Max completion tokens, this is the number of output tokens. So the max tokens is the input and out. Now what is the input? Input is the prompt. So for example here, describe what is happening, and then either image, video, or multiple images, multiple video in this case. So what we'll do, we'll upload first the image and then later we'll go into the video. Now for the image, we'll choose the most unique example in the AI general space of what we can do. So if we click here, yes, we uploaded image of a cat. Yeah, I know, I sell myself for views. And we'll use this image to first run it. I ran it before because the vLLM before have warm up as default, but now I think it's gone again. So I need to run model once or we get really long first request because of computing CUDA graphs and so on. So we get the response. And what I also trigger is to show reasoning output because what we see here, all of this basically from think token to the another think token is the model thinking. So basically here. And we see that it kind of stopped in middle way, The yellow green eyes appear a bit sleepy, the fur, the cat, and then it stopped. But we don't get the description. Why? Well, because we set the max completion tokens to 1,000. So basically we achieve the limit of the tokens that we can produce on the output, and that's why it stopped. So now what if we do 19,000? We will wait again. And now we'll see that we'll get much higher number of tokens, but we'll get the response at least. So this will take some time, So 12 seconds, So this takes also quite long, It's 12 seconds for one image. But now we can see here are the specific details, what's happening. The cat is upside down, state of comfort, truss, front paws stretched, upward in the air, visible in the top left. So that's what happens on the image. You can look here, picture of a cat. So we set it to 19,000, but what if we do 21? Because we want more output. We can't because we defined that our output is higher than our total number of tokens with prompt and image. So this is impossible. So now how to make it faster before we go to other steps? Well, we can lower this to 1,000 again. And now we can change the prompt, for example. Define in one word, yes or no, if there is cat on photo. So this is all with thinking. We run it, we wait, and 4 seconds we get answer no, which is actually quite funny. I mistyped. So that was right. It's better than me at typing. So now if I do cat again, we see yes. So we find the cat in the image and we can see there was small thinking and so on. But this takes 4 seconds. Can we make it faster? Well, of course we can do because the Qwen 3.5, it have thinking mode, so the reasoning mode. So when it basically have these thinking tokens that we have here and so on. But is it needed here? We classify just the cat. It's like not really needed. What will be the best tool is to have budget for thinking and then define based on the use case if we, for example, want 1,000, 5,000 tokens like on Google AI Studio on for adult models, but because this model just came out, there is no optimization for this option yet on the engines from what I checked. I read that it's in the Qwen API and so on, but basically we can't control it. So now what we do, we turn off the thinking and we run again, and we'll see how long it takes. And instead of 4 seconds, now it takes only 2 seconds, 800 milliseconds. So we lower it again, and then we get one output, which is yes. Yes, there is cut. Good. So now, what will happen if we upload more images? Let's add another cut and run this. And we have error code, maximum context length, 20,000 got exceeded. Now, what happened? We just have 2 cut photos and that's it. We can't work more on 20,000 tokens. Well, yes, because these cuts are in pretty high quality. Like if you look into it, I get it from some free website of cut pictures, basically. So this takes a lot of space and we basically achieve limit on our tokens. So now what we can do, should we go basically here and in the Docker rerun everything and increase the max model length? Well, we could, but there are better options than this. Basically, what we can do is we go into next step. So this is what I added. So let's turn on pre-process images and we have target max height of the images. So now it's 480. Let's see if it will work. It worked. And it's faster. Now, what happened? Well, these images are in high quality, yeah? So they take a lot of pixels. So basically, we lower in the pre-processing steps. Now we can look into here. So we use 500 milliseconds on pre-processing of this image to basically lower it to lower amount of pixels. But because we do it, then the request only take 100 milliseconds and we get total of 665. And the output is still good because we have 2 cuts, yeah? So that's what you can do because we will think like humans that we want best possible image quality to get the same output, but we don't know exactly, maybe if we read paper, how the model see the image, the pixels and so on. Now we got it in 600. Can we get it lower? Let's lower it to 128. No. So we see we lower it too much and it couldn't recognize the cut. So what if we do 256? Yes. So there is optimization, but basically depending on your pictures, you can optimize these things, yeah? So we have 2 cuts. Now let's do maybe some harder prompt. Count the cuts photos and output only number as numeric. So we have 2 cuts, we run it, and we have 2 cuts. So it's good. Now what if we lower it? Still 2 cuts. So for counting, this is good. For recognizing if it's cut or not, it actually failed, which is interesting here. We could have turned on thinking there actually to see and so on. But see, it's 600 milliseconds, and now I turn it off. This will take few. So yeah, we exceeded again. So let's say something around 1,000. Will it fit? Yes. So basically the resolution is much higher than this and we still get 2 cuts. So now let's get more. So we have 3 and now here on this we have 5 cuts. So 6, 7, 8. Let's run it. It got it right. So the first image, 1 adult sleeping, 5 kitten in the grass. So this is on 1000. And on lower resolution it don't recognize them. So as we can see, we lower it because we have 800 milliseconds here. On 1000, we have basically 1800, but now it also makes mistake. What if we put it on the maximum now? 180, run 6. So see, it makes mistakes if you run it. Now let's turn on thinking and let's make it 90,000. You can still go over the number of tokens here. Yeah, so after thinking, it got us 8. Let's do it again to see if it's consistent at least. I mean, it's not the best test, yeah, we could run it 100 times and then see. But yeah, it gives 8 again. So yeah, this should visualize us, basically the influence of these parameters and so on. But I wanted to just show you because I always print the result JSON at the bottom, but I don't go in deep into it, yeah. So here I provide the images from the cuts and then we can see the video path all the parameters we use, video sampling, but this we don't use yet because we don't do video. And then the timings, effective parameters that we set up from the tool, and so on and so on. And then images. So we can see actually also the original height. So it was like 6,000, 5,000, and 1,300. But we, for example, we process it to 1080, yeah? So that's why we save so much of memory. Okay, guys, so for the last two parts, we go into video. So basically, I uploaded video where I'm speaking. This is raw footage of one of YouTube videos. So if I run it, I set basically parameters like this and thinking mode off for the sake of time. And as we can see, in 7 seconds, we go over 1 minute 40 video and it counts the person, which is me. You can also do describe. And by the way, if you notice that I changed the frames from cut to cut, it's because my PC crashed like 5 or 6 times because the visual AI works very bad with OBS. Okay, desktop, associated technologies. So yeah, as we can see, it recognized this and we run it without pre-processing, yeah? So now if we do describe thing in detail and we turn thinking, and you can see we can also summarize the video. Yeah, so this works. With thinking, as we can see, time becomes much higher. And now the interesting parts is that if we do video preprocessing, maybe first without, so this would be the baseline. And now if we do preprocess video, we can lower it to 480, but for me, I find out that 360 works best. And then target video FPS. So first, let's do it like this. So what it defines is the frames per second that are captured. So before we send video, it got changed to 30, for example. So here we see that we lower the speed quite a lot and we get nice summary. And if we go into speeds, we see on preprocessing we spend 1.6, then the request take 5 seconds. And here we can also do, because we aim for 2 frames per second, and here also in vLLM for the 2. Why 2? Basically, I read about the model somewhere in the card that they suggest 1 or 2. And from what I saw, it's enough. So that's what I use. But we can also check if the maximum works. But I think it will be hard because I tried before. So as we can see, we lower the time again. So we can also lower it to 1. So 1 frame per second is captured. So of course, it comes with some accuracy difference, but for most tasks, we can find out that this lowers the speed and provide us good result. And as we can see, by just spending 1 second, 200 milliseconds, we basically reduce the request to 3.5 seconds, which is pretty good. This I will not go into detail because this gives me some errors because there is still issues with some parameters on vLLM. So for the sake of time, I'll skip it. And basically the plan is to have the benchmark and then actually I get whole history of the requests I send, but because it's very hard to find images without copyright issues and videos, I think I'll use Qwen model to generate specific use cases of videos and then check it. Maybe classify something and so on. So that will be the idea. And then also at the end, what we can do, we can lower this. So now the vLLM will also use 1 frame per second. This is something I played with, basically provide other headers. Yeah, I forgot I added option now to have 2 videos because I thought, why not? So what we'll do, we have this, we lower all of these settings as much as possible. This got in 2 seconds. And now, so I upload these 2 videos, and now what I'll do is I summarize these 2 videos and the difference between them. And as we can see, we have 2 videos. I turn the mode off. So we exceed number of tokens. So let's do 128. Okay. Static website, coding session, students looking to understand the process. So as we can see, there is difference between these 2 videos, and we have video path past of these 2. So we can count it and like, let's do, so yeah, it recognized me as different person on these 2 videos. And now let's do test with thinking. So just so you see, here I'm in shared name. So it classify me as woman. All knobs of the parameters we can use, because yeah, this is 1 video and this is me on 2nd video. Bottom right corner, so it classify me in a chart as a woman. So yeah, interesting. And now if you guys want to run it, hey guys, so this is like my 10th crash during recording this video, so I will go quickly over it. I already ran the enable prefix caching and I commented these parts that we made so the image will not be caching if we use it. So now I can do this again. If you want to run it, just do all the files will be in the repo. There's by project Tom with everything. You just do UV sync, and then you UV run Python experiment 7 lab main. This runs, and then you can just control click it, and you have the GUI. So quickly update one video, and if we look, we have a ffmpeg hit rate, which is for the video images, then prefix is for the prompt, and then kvkh is for text generation. So if we run it again, we get the 200, and the cache hit rate for prefix increase, and for image actually decrease a bit. So I think it do some smart setup, deciding what is important, what is not. But now you will run the cut, so there is no, and now the kvkh hit rate go high, and we see we get response in 300 milliseconds. But we see that I ran it multiple times, and the cache hit rate increase to 50.7. That was the point of the video. So that's it. If you want more, I think in the second part I will do segmentation. So like if you have multiple segments, we can guide multiple segments to, for example, if we look at the Docker, what we can do is that we can increase number of sequences here. So if we do multiple sequences of video, we can chunk like 30 seconds of 2 minutes video to 4 chunks, and then send 4 chunks at the same time. And vLLM is pretty good in managing multiple requests. And then because this is all kind of part of the same video, the cache have like a very high hit rate, which will further increase everything, and so on. And then also there are multiple strategies for this and things to improve it. So yeah, like and subscribe, write a comment what you want in the next video, and see you.